Good morning, everybody. Welcome to today's WWT Hands-On Live Lab. Today we'll be covering NVIDIA Base Command Manager with Chris Braun and Chirag Patel. A couple of housekeeping rules as we go through. At any point in the presentation today or any time in the lab execution, please drop any sort of check questions you have into the WebEx chat, and I will do my best to relay them to both Chirag and Chris to be answered throughout the presentation. So with that, I guess I should introduce myself. My name is Brandon Swagman, your host for today. I would like to introduce Chirag Patel and Chris Braun. Do you gentlemen mind coming on camera and telling us about yourself?
Hi, welcome. I'm Chirag Patel. I'm a technical solutions engineer on the AI program team of ASD. Today we'll be talking about Base Command Manager. I'll let Chris Braun introduce himself.
Yeah, so Chris Braun, I'm also a technical solutions architect on the AIPG team with Chirag. Both of us have had experience with BCM, so we'll be walking you through today, kind of deep diving into how to use it and how to manage it. So thanks for coming along.
Thank you, gentlemen. So before we get too deep into this, I guess the question for you guys, Chris and Chirag, what kind of consumers would you see using NVIDIA Base Command Manager?
So in my opinion, Base Command Manager is meant for the data center engineer or architect that is creating a cluster for mainly to use for AI workloads or ML workloads. It's using a cluster that has several nodes or servers that include GPUs in them. They're going to utilize their processing power for deploying in this nowadays. You know, we have large language models. Now we have AI agents, but it's going to be using this infrastructure. And it's basically bringing the nodes together, servers together, to help orchestrate and monitor the activity that is running on those servers. So I'll let Chris add to that if you need that.
Yeah, I mean, Chirag kind of sums it up pretty well there. You know, it's really Base Command Manager is the NVIDIA stack for managing your AI workloads, right? So, you know, everything NVIDIA is going to run through Base Command Manager. There are other options that you can use to monitor your AI stack, but this is something that, and we'll go into the terms here in a second, but this is something that is definitely NVIDIA all the time under the covers, right? So this kind of helps you keep in that supported matrix when you're talking about a base pod or a super pod.
Thank you, gentlemen. Chris, you mentioned the terminology here, and I know you got quite a bit prepared. So do you mind diving into the terminology to help everybody just understand all the different components that make up the system?
Yeah, sure. And we're going to read these verbatim, word for word for everybody. No, we're not going to read them verbatim. That was a poor attempt at humor. But these are some of the terms that we're going to touch on today. We talked about BCM, right? Base or we call it Base Command Manager. Again, that's the clustering software that we're going to use. You'll hear base view and CMS shell as we go through it. Chirag goes and does the presentation around the live lab itself. Other things to note, like head nodes and worker nodes, those will get explained on how, you know, we set up the system here. It's very, when you use Base Command Manager, you have an architecture that you're kind of trying to support and create. And these things like head node, worker nodes, control plane nodes, what InfiniBand is, you kind of have to have a little bit of idea of what they are. But again, we'll go through these in more detail as we go through it. It's more of just maybe taking a screenshot of this so that you can relate that back as we walk through the presentation. Because I know everybody wants to hear me read these verbatim, but we're not going to do that. One of the big things that BCM does is provisioning of the systems, right? So we'll go through a little bit of that. I know Chirag is going to show some of that in the demo, right, as of the live lab concerned. And then the other thing we're going to touch on briefly, we're not going to go too deep into it, is the type of network design that you want to use for BCM. Our type is a type 1, where basically you have a head node at the top, and we'll show you what a kind of a high-level design looks like, and we'll go through it. But that type 1, where the head node acts as your gateway and routes all the traffic to it. So this is kind of what the lab looks like, right? When you're going through it, all the stuff that we have is virtualized so that you can do it. And Chirag, you want to touch on any more of this from a virtualization standpoint?
Yeah, so so we have the three different type of network topologies that NVIDIA supports. They recommend a type 1. So that's where our lab is centered around. What a type 1 is basically the head node, which is, it could be a virtual node. In our case, it is virtual, or it could be a physical server. So it acts as the controller node for all the equipment that's within the internal network. So the internal network will be a private network internal to the BasePod or SuperPod. And basically, it's the base command manager is on the head node. The head node is the DHCP server, it's the TFTP server, and it's the gateway. So it's the gateway out to the network. So this is what so we've created this in a virtual environment. This is all within a VApp, if you call it, so all the different VMs that act as the compute nodes, which in a production environment would be your DGXs, right? The server nodes that have the GPUs on them, they'll be the workers. So when we say worker and control plane, Chris talked about it in the previous slide. So the end goal of Base Command Manager is to be a platform from Kubernetes to run on. So that's why you have control plane nodes and you have worker nodes. And the head node is the one that's orchestrating that, keeping track of the out-of-band management and the management network for the nodes that service it. And nodes could be the servers and other devices also. So within other devices, we have switches, including the InfiniBand switches and network that Chris talked about. And that InfiniBand network is a network that connects DGX to DGX, or basically gives high-speed connectivity from one GPU on one server to another GPU on another server. So this is basically the high-level overview of our topology for our virtual lab today.
Great. Thank you, gentlemen. So I appreciate getting into the terminologies and the high-level designs here. A reminder for the audience, any sort of questions you have, if you're deploying or running an NVIDIA cluster today, are you running BCM in your environment? Please ask questions in the WebEx chat, and I will do my best as we grow through and move into the demonstration phase.
And also, Brandon, we'll talk briefly about the physical. So in a production environment, the architect or the engineer that's standing up a BasePod or SuperPod will usually work with a high level of physical architecture here, reference architecture. And Chris, did you want to talk more about it? Because Chris has experience with deploying this for some customer PLCs also.
Yeah, I mean, this is what the physical environment, while that first slide kind of showed just the virtual environment, what we have to do, this is like what we base a lot of our learning paths on. So we'll go out and set up HA and do videos on the head nodes or on deploying a workload. So we have our own little base pod. We don't have a SuperPod because SuperPod, you have to have a lot more gear and a lot more power. But we have our own base pod here at Worldwide where we're going out and doing these steps from NVIDIA, trying to get the learning paths in so we can educate customers faster. So if you get a chance to check out the learning paths that Chirag and I have done around BasePod, we've got 2 out there today. We'll be going through a lab that, again, we virtualize some of these things so that you can walk through some of the easier steps, but it helps you get ready for when you actually go out to deploy your physical environment like we did in our infrastructure. So there's a lot more things that go behind the scenes for the physical environment that not necessarily are part of your virtual lab. And I just want others, and I think Chirag does too, other people to understand what it goes to set up the physical space as well. So what you're seeing here is like, you see the head nodes, you've got K8 nodes, all those are physical Dell systems. You've got the 2 GGXs that we've got band together with InfiniBand at the top. And then we've got our server or switches there in the middle for network traffic. And we have a NetApp that kind of hangs off here that gives us some NFS storage that we've set up. So any questions so far around the physical environment or any questions leading up through the virtual environment that we talked about? If not, we'll send it over to Chirag to kind of start walking through the live lab. I don't see any in chat, so I think we're good.
I think we're good. Go ahead, Chirag.
So to get to the live lab, we go to My Account, and then you go to My Events. And then this is the live lab right here. We click that, And then this this lab is actually within the day 2 learning path. There's an introduction learning path for BasePod, SuperPod, and then there's a day 2. So the day 2, when we click the resources tab, we'll see the learning path right here. Any questions so far?
No, sir. Looking forward to getting inside of the learning path and lab.
Okay. And I'll also show the alternate way here. You go to Learn from Us, Labs and Learning. And then we could go to Explore. And we just type in NVIDIA. And then we have other NVIDIA learning paths also that you're free to explore. Okay. Click here. And then we're going to launch the lab.
And while this lab launch, while Chirag launches the lab, just a reminder, you need to be a customer or partner or accessing the learning path through the event to have access on WWT.com.
Okay. So in the beginning, this is a jump host. So it's a Windows jump host connected to our head node. And to start off with, we could see the lab topology. If this is too small for you, you could click this expansion icon in the lower left corner and open up another tab, and it'll give a broader view. If you have multiple monitors, you could put that tab into another monitor as you're running through the lab also. So the topology of the lab, so this is our Windows jump host. We have a virtual switch linked to a VM head node. So the head node is actually, in the physical environment, it's a Dell server or it could be another vendor's server. And it's a version of Ubuntu Linux that's customized with the packages required to run Base Command Manager. So then this head node is connected to an internal virtual switch, and we have 2 compute nodes which are acting like in the real environment if there would be DGX nodes. Any questions so far about this topology?
No, sir.
Okay. Okay, and then we're gonna move on. So when we open up the browser tab here, it'll connect directly to the login page of the head node. So that's what it's saying here, and has the credentials also. And we'll walk through that in the next tab. So we start off by opening our web browser. And then you'll see this welcome to, you could close that tab. And then you'll see the login page, and they call these blocks. And there's documentation you could reference also. We're going to click the base view block here. And then we'll log in using the username and password right here. Click the login button. Now we are in the main dashboard of Base View. So from here, we will go to the next tab, or the next part of the documentation, and we'll explore the different components of this dashboard. So there's different toggles. It'll talk about the task at the top right here. We go from light to dark mode. And then we could do search. We could search for features within this management wizard. So we could say like monitoring. I spell it right. There we go. And then you can see the different components. If you want to just search for different features of Base Command Manager, you could do it this way. And then we won't go through every single one of these, but you could see the icons here. And then different features. If you had accounting set up for a Kubernetes cluster, you could do that there. If you wanted to charge for different jobs, we're going to discard changes. You could do that here. Any package updates would be this icon. We would see it here, we'd click it, and we could update it that way. It's not really supported in this version, so we would do that through the CM shell, which is the terminal version of Base Command Manager.
Hey, Chirag, when you say package update, can you kind of detail what exactly is in a package?
So packages are different features of Base Command Manager, different components in the background, such as the Pixie boot, the images that are being sent to the worker nodes or any nodes in the BasePod also. Yeah, so things like that. New versions of Kubernetes, if you're going to deploy new versions of that. So, and then these are various events that have happened. You could see the icon here says green if it's okay. If there's any additional information, you could click into it. Or you could expand it here. Failing health checks, you could explore that further. And then any actions are, if we make changes to the configuration, we'll see this later on. If we make any changes, we would see it here. We want to make sure we hit save. If we don't do that, those changes won't take effect. And then we scroll down. Okay, I saw Chris answer the question there. So
we did have a, sorry, Chirag, we did have a question, and I believe you're going to get to it later in the lab, because I believe I've seen it, but is there a spot within BCM that will show you power consumption, power usage of a node?
Power consumption, I haven't really dived deep into it, but there is information about the racks here.
So you can do that but you have to have smart PDUs to do that, right? So if you wanted to see power from a DGX as it's running, you have to integrate that into a smart PDU, and you have to have smart PDUs in your data center. You could create custom Grafana graphs if you wanted outside of it to monitor it from an aspect, or you can go to the DGX itself. But specifically using in Base Command Manager, you'd have to incorporate a smart PDU. And I will tell you that when we did this, when I did this a few months ago, it has to be a very specific PDU. I think they only support APC PDUs, or the ones that verify the OIDs for the PDUs. So it can be done. They're very rigid in which ones you can do. You can't just go out and get a Veritiv or whatnot. They have to support specific AP PDUs. Sorry to interrupt you, Chirag, there. Just throwing that question.
Yeah. So we're going to now jump into our resource navigation right here. So resources are networks, devices, PDUs, etc. So it starts off with the, they call this partition base window. So basically it shows everything from a high level of the cluster. And it has the occupation rate, it has the memory usage, GPU status of the GPUs in the cluster, etc. And then it shows here for the head node, it shows the different partitions, the Linux disk partitions and their usage. And then we go to settings. In settings, we could see different configurations for the cluster. We could see IP addressing, other aspects like that. And we could also change the settings here for it. So the password for BCM for all, or BMC, so baseboard management controller for different nodes in the cluster. Any questions so far?
There was a question in chat, and Chris just answered. Is Run AI integrated into BCM for the purpose of the lab? And unfortunately, it's not today as part of this.
No. And then, so with Run AI also, they're having, this is Base Command Manager version 10. I've been told that they're going to incorporate that in the next version, so from NVIDIA. Run AI has been purchased by NVIDIA, so it's going to be NVIDIA company. Next tab will go through the licensing information. This is a evaluation license. So the license is based off of how many nodes are supported and how many accelerators or GPUs are supported with that particular license.
There's another question in chat. As I heard storage nodes are NFS. Is that correct? And if so, wouldn't that be a bottleneck since connected to via InfiniBand?
You could connect either way. You could do NFS through regular networking, or you can connect storage through InfiniBand. I mean, it just depends on what kind of storage array you have. So to answer your question, there's a couple different methods you can choose, right? You could do InfiniBand storage with like a DDN or something like that. Now you could even do some storage vendors will let you do GPU direct to their storage. So, but to answer your question, there's multiple different ways you can do storage. NFS is just kind of what we've used in our physical environment to do it, but you can do multitude, right, Chirag? I mean,
Yes.
there's plenty of different ways you can proverbial skin the cat.
Have you guys noticed one having a higher performance threshold than other? I know we typically use NFS in a lot of things just for the simplicity, but have you noticed to the bandwidth constraint question or bottleneck question, have you noticed an advantage to one way versus the other when it comes to storage?
I mean, we've done a lot of testing, and Brian Peruka, who's not on here, but he's our storage guy, and he will tell you to probably dedicate that through like the InfiniBand method versus just doing NFS, because you can get higher speeds to your point, like 200 gig InfiniBand or 100 gig NFS. You know, which one do you think is going to be faster, right? So again, it's about what you need. I mean, there's no fiber channel in these things, right? I probably said a dirty word there, but you know, you can do it which way your workload is, right? So NVIDIA is not as rigid as they do have specific storage vendors that they support, but they allow you to do, if you even wanted to do NFS, or you could set up a Ceph cluster on these guys too for local storage. So they give you a couple different options to use, but if you're going for performance, you're probably going to want to stay down the InfiniBand path if you need that super, high speed storage. If you're dumping your job to run on the GPU, you may not need as much high powered storage as you think. It really depends on your workload.
Thank you.
And they have a Ceph implementation. It's not fully stable, but they are working. NVIDIA is working on something where you could do Ceph. The only caveat to that is Ceph needs to be a dedicated storage cluster. We can't use the storage devices currently with the implementation for like existing nodes have extra storage disk that we can incorporate into Ceph. If they're workers, they're workers. If they're head nodes, they're head nodes devices, the storage devices. So I did notice that in the implementation of Ceph.
Wonderful. Thank you. I'll let you get back to BCM. And I appreciate the questions as they come in through the chat. Thank you very much to the audience.
So the scroll in this is not working that great, but you could see that the node, it says 3 right here, and accelerator is 0. So this is a older implementation, or older license. The new license for BCM will allow for 8 nodes and up to 8 accelerators, according to their documentation. We have a limit of 4 accelerators, but in our lab environment, we don't have any GPUs attached to the VMs right now. And then the next tab will be our system information. We also have version information, build numbers for Base Command Manager, the software. And then we have the run tab right here where we could run individual commands on the nodes. And we'll talk about that a little bit later also. Okay.
Hey, Chirag, do you mind going back to system information? One thing I noticed when I walked through this lab was the VMware component. I think I actually sent you an instant message as one of the OS versions called out VMware. Do you mind kind of explaining how, and you kind of hit on this earlier, how this lab itself is virtualized? So you will see the name VMware in here. Do you mind kind of explaining the lab setup and why you'll see VMware in this?
Yeah, so we virtualize the servers themselves, the hardware, the CPUs, the storage devices, things like that. So this system, BCM will recognize what system the nodes are on, the platforms. So if it's a Dell system or if it's a DGX, it'll actually say that in the system component here.
Wonderful. Thank you.
You're welcome. So yeah, right here. Okay. So on the run command, so we have two worker nodes. We have the head node itself. So we could actually run commands remotely from our interface. So say we click here for the nodes. We have a head node and two worker nodes. So node 001, node 002. We could actually run multiple commands or one command on multiple devices. So let's say I want to run the command on node 001, node 002. I select those nodes. And then I click here. I just want to do a ls -l. So for the root directory of both these nodes, I want to run the directory, see what's in the directory. I click that and I click run. And then right here, I could see the output. And this is a powerful diagnostic component also. So if we wanted to see like anything else, yes. If we want to do, if we wanted CD, CD won't work. It's not interactive, it's just straight output. And we could join the output this way also. Let's just run that ls command again. Right here. And we could compare, see if there's any differences or things like that. And then this is a future view of the rack. So they're going to have implementation where you actually see devices within the rack. Your server rack, you can see different nodes, where they're located, and different components inside of it. And then we'll move now to the networking resource in the resource tree. From here, we could see the various networks that are implemented. So these are subnets that have been implemented in our BasePod infrastructure. When we click networks, we see currently there are 3 different networks. We could expand it this way. The external net, so this is a type 1 configuration. So in a type 1 network topology configuration, we have the external net and internal net. So our external net is from our core, so it's out to the internet, to Base Command Manager's head node device, and then that's the head node is the gateway, and it NATs to the internal network right here. So that's what these are. The global network is just the gateway of last resort, so that's why it's shown right here. Any questions on that?
Oh, another question that came in chat, and Chris, you did a little bit of answering here. I'd love to talk about it out loud here. Is DGX systems sound quite powerful. Are most teams using them in production or still in testing phase? And Chris, I'll point this right to you because I know you have some experience with the different customers coming into the advanced technology centers hosting proof of concept testing. So I guess, Chris, question for you is what sort of patterns are you seeing when it comes to proof of concept testing DGX systems?
Some people want to just get their hands on it and see what it does. A couple of them have been pairing it with Base Command Manager, and then there's been others that are doing more of an AI and a roll your own, right? Where they'll take a DGX, because the DGX OS, while it's branded, it has all the drivers and everything for you and get ready to use for BCM. You can still use this as a compute node in like in a RHEL setup. It will accept RHEL, I think it'll accept RHEL, a couple different versions of it. So I know this is about BCM, but you could use this in a roll your own environment too. And we've had a couple POCs that have done that, where they're like, well, we don't want to use BCM as our automation tool. And those ones, probably use Run AI before it was, bought by BCM. But that's not the only thing that can automate, whether that be BCM or Run AI. There are other things and other homegrown tools to use it. So yes, we've seen plenty of POCs that do it or roll your own or integrate it into BCM. Either way, again, this goes back to that, what your use case is. And I think it also goes back on how far are you in your AI journey. If you stick to the BCM pieces, you have full support with NVIDIA, right? That's a good thing for most customers, right? Because they go into a journey and they're like, how do I get all this to work? Well, you kind of pay for that with support. And then there's the people that are more experienced with an AI workload or whatnot, and they may not need NVIDIA support, so they're going to go roll your own and go down that bridge themselves. So again, not to beat a dead horse, but it's really a pick your use case scenario.
No, it makes sense. And it's a great response. And even kind of summarizing some of the questions and some of the dialogue we've had here from Run AI that's coming into this platform. BCM itself is a new platform. There's a lot of changes taking place in this environment. So I guess would it be fair to say a lot of customers are still figuring it out, how to put that initial architecture together?
Yeah, when they first come into us, I think they have an idea. They're figuring it out, right? It just depends on which way they want to pivot. Full supported stack or more. They can still get a full supported stack the other way too, but you bring in more vendors in that solution. So it's really all NVIDIA play. It's a semi-NVIDIA play with a bunch of other partners in it. Really, that's the decision that a lot of people have to make.
No, thank you. And I appreciate that. And we can get back to the lab itself, because from the Worldwide Technology, we have WWT.com, where a lot of this labs and learning content that Chirag is walking through today. We're fortunate enough to have Chris Braun with us, who is engaged in a lot of dedicated and specific proof of concepts in nature. So with that, Chirag, I'll turn it back to you and BCM.
Okay. The next resource will be switches. So this is where we would see like our InfiniBand switches or our management switches. If we had physical management switches, we could add them here. We could actually like monitor them. There's some switches that are supported where we could go in and actually change some configurations. DHCP leases are seen here. So I understand the server is always going to be head node in a type 1 configuration here. So, but these are the MAC addresses and the IP addresses assigned to various nodes within or servers within our BasePod. And we'll talk more about this when we go into provisioning and how we could identify which nodes have been assigned what and how that entire process happens. So has anybody provisioned servers in their production environment, done any PXE booting or anything like that in their past?
Great question. Yeah, I'd love to hear. Has anybody done provisioning PXE booting? Please put it in the chat. So while we wait for some answers there, one of the kind of conversations we had before this is, how does BCM compare or contradict or work together with NVIDIA Mission Control?
So Mission Control is actually a new software that's coming out with NVIDIA. BCM is actually going to be used as a provisioning layer within Mission Control. Mission Control is meant as a control center for the entire data center. It's going to be linked, its goal is to be linked to the cooling, the plumbing, the security of everything, rack level, node level. So if entire rack goes down, it'll be alerted. You put automation in where it could take those workloads off that rack or off that individual server, put them onto a different rack or replicate it. So that's the end goal of Mission Control. It's still not public release. They've had some webinars about it, NVIDIA has, and I've attended those, but that's their end goal, is to incorporate Base Command Manager within Mission Control going forward with their new platforms. So especially with their Rubin and other accelerator platforms.
Makes sense. And where do you see, we mentioned it earlier, Kubernetes, a containers play. Where do you see BCM coming together, and how does it help manage or work with Kubernetes stack?
Perfect question. So BCM actually helps, it has wizards to actually spin up the Kubernetes cluster. So it'll, once you have built out the control plane nodes and worker nodes with their base images and set them up to be provisioned by BCM with their configurations, the wizard of BCM will create, you'll go through a step-by-step process of assigning control plane nodes, worker nodes, and etcd nodes. And then it'll step through the process of creating that, standing up that Kubernetes cluster. So any of that has set up a Kubernetes cluster, it is a long and tedious process. And BCM makes it simpler, a lot simpler in my opinion. So I don't know. We've done it with Chris. We have a video coming out pretty soon on our day 3, but I'll let Chris talk about anything else if he has more experience with that. Yeah.
Yeah, I mean, the beauty part of doing it through BCM is, again, you don't have to go out and find all your drivers and everything for you. It's incorporated. So when you run through that automation setup, it's actually really cool from a built-in standpoint to do that. So it actually goes out and gets all your packages and updates them for you. It's really easily wizard driven. We've done it a couple times and we were surprised at how easy it was versus you going out and trying to standing up a native Kubernetes cluster yourself. There's a lot of things, again, that BCM simplifies that you don't have to kind of worry about as you go through. And that's the beauty of running a software solution that kind of automates some of that stuff for you.
Thank you.
So provisioning includes several aspects. So in the provisioning resource section of the resource tree here, provisioning is basically bringing up nodes using Pixie Boot, right? So what we need some images first. So BCM comes with versions. So BCM is initially, it's made for, but not solely for BasePod. And BasePod includes DGX nodes as our worker nodes in the Kubernetes cluster. So when we start with software images here, we'll see, I'm going to expand this out so it's more visible. We'll see 3 default images that have been built out for us. And these images will be used during Pixie Boot. Yes. So sorry, I'm answering the question.
Sorry,
here.
Great question. Let me repeat that out loud. So can we use a single BCM instance to manage DGXs across multiple locations? And I'm assuming geographical locations with the old network latency in the middle.
Yes. So that's where the different type of network topologies come into play also. We're here doing a type 1 topology. That could be done in a VPN environment throughout a corporation. But if you didn't want to do that, there's something called type 2. So where you won't have external network, internal network, you'll just have the network and it's connected to each other. So basically it's all an internal network according to the installer. I think the wording is kind of bad in that regard, but so basically you have a route to each node, or there's a type 3 where all of them are routed out, right? So you have an internal network to the corporation. So like if you're on our network here, we're connected to VPN usually. So even if we're like across the world, we have the VPN network. So it's routed through a common router that way. It's not routed through the head node of BCM, right? Or you could have it where there's instances of BCM that actually exist on the cloud. So today supported are AWS and Azure, but the head node could exist in one of those cloud providers, and that head node, the virtual head node, right? So it's going to be a virtual instance of a server with the head node BCM installed on that, but it could connect to your corporate DGXs. It just has to have a route to it. And there, within the head node also, we could extend out to the cloud or to other instances using a wizard. So BCM actually has a wizard, and we could actually, we haven't got there yet, but I could actually show you here. So that's what this is about here. So they have Azure here, but there's AWS wizards for storage also. But yes, you could have BCM exists on like a home at the headquarters HQ, and then it connects to DGXs across the world. That is possible. And that would be a type 3 configuration if it's not within a corporate network, if you want to just route out to the internet and connect that way. So
thank you. I appreciate the question.
Okay, so going back to provisioning. So we start out with the base images. So the default image is, so all 3 of these right now, we did the default configuration during installation for BCM, and that is Ubuntu. So Ubuntu, I believe this is 22.04. There's a 24.04 version also. The default image is if you wanted to just do plain server nodes with compute, no accelerators. And when I say accelerators, that's terminology in our industry for GPUs also. So if we wanted to stand up our Kubernetes control plane nodes or any other nodes like that, we would use the default image and we'll map to it. And I'll show you in the next section of how we map that during like how that's configured for provisioning when it does Pixie booting, identifies what image to use. I'll show that next. We have the A100, DGX A100s, and the H100s. The new image of BCM also includes the new B200 DGX images. So what's the difference between all three of these is drivers and support, hardware support, right? So when you install this image right here, this DGX OS image, it'll have the necessary drivers and packages to support the A100 GPUs within that node, right? Within that DGX A100 server. And same thing for the H100. So when we Pixie boot to this image and we go into that individual DGX A100 node, we can do NVIDIA-SMI and it'll recognize the GPUs that way. Any questions?
Not at this time.
Okay. Okay, so when we do provisioning status, so provisioning nodes tells, so in BCM, you could have the head node be the provisioning node, or you could assign other nodes within the BasePod cluster or within the cluster be the provisioning node. And that basically says that during the provisioning process, during the Pixie boot process, that the images will be pulled from these nodes and these specific images. So the provisioning images, it right now maps to these three images. We could add more, or we could remove also. Provisioning request, anything that's still pending provisioning, it'll show here. We've already done the Pixie booting in our environment here, but if it was happening, you'll see that status update here. And then provisioning node info. This gives a clear picture of how the provisioning has happened. So the nodes that did the provisioning were the head nodes, in our case, just one head node, and they're provisioning node 001 and node 002, which is our compute nodes in our cluster. Okay. And then the different file system parts for the head node are right here. We have a shared storage partition within the head node. And then we have the different components of the images that are going to be Pixie booted during the big Pixie boot process. And we have the directory for the TFTP boot. TFTP is the protocol used for Pixie booting. So has anybody used TFTP boot before, or are they familiar with that?
Yeah, so if you've engaged in TFTP or Pixie boot in chat, please post answers. And the first answer is yes.
Okay. Good. Okay, so the next section is grouping. So grouping is where we could bring the different categories of nodes. So for example, for Kubernetes, right, we have a group of control plane nodes. We have a group of worker nodes. We also have nodes that could be assigned for storage. So that's the grouping. So we start out with how NVIDIA's documentation wants us to start out with is we want to create categories, right? And based off of the categories, we would assign configurations such as disk partitions. Oh, sorry, we have a question here.
Yeah, so the images to load, do they load from local disk or just extract on flash and run there?
Yes, yeah. Yeah, they extract, in our case, there's also provisioning. There's a mini version of Linux that runs on the head node that gets deployed on the node it's provisioning. So the head node will deploy a mini version of Linux on like a DGX, and it'll go through the process of whatever configuration has been set. So what image to pull, the IP addressing, and things like that.
But it does flash it down to the server itself.
Yes, yeah. So the categories, we have 3 categories here. We have the default category, which is our head node or any node similar to that are just like in our case, it'd be a Dell server that doesn't have any GPUs in it. And within that, we could do different configurations. So we click this drop down, we click edit. Should let me do it. Sorry. When we click edit, it brings the tab over here. And then we could see various configurations like the default gateway, what management network. We click that. We could use external or internal, the software image to use. So this is where we would map that any node that's in the default category will use this software image during Pixie Boot. So default category using default image, we could change it to DGX OS 6.3 for A100 or H100. And then we have we could also change the name servers, or it'll inherit these configurations from the head node. And then we could add any scripts or anything like that here. And then disk setup. So something we noticed in the physical environment, we didn't see in the virtual environment, was the default image or the DGX image we use for our DGX nodes in our production environment, the disk layout. So I'm going to click edit here so we can see. So this disk layout here, creating the partitions, was incorrect. So our Pixie Boot crashed. So we had to actually customize it where it would recognize the correct number of disk and create the correct partitions. And then I don't know if Chris wanted to add to that or anything like that. He helped me do that in our production environment.
No, I'm good. You think you covered it. I mean, it was just a matter of making sure that we had the right partitions. One of the things I think will get into as you get into the physical side of the world is making sure that you have all your disks selected that you want to do. You can get really powerful with the provisioning. You can set up RAID group and all kinds of things inside there, how you want to do it. The default image only does so much, pushes it to a certain point, but you can, when you walk through the provisioning parts of this, you can, pick and choose what you want to do for each one. So the good place, like Chirag stated, starting at the default, and then you kind of can expand there as your knowledge grows.
Perfect. So I just want a reminder here, we are coming up on the top of the hour. So if you have any questions, please post those in chat now. Chirag, Chris, I'm going to ask you both a question here. As we're inviting users to come into WWT.com and enroll in the learning path and launch the lab, what is the main takeaway each of you would ask that particular consumer to grasp onto, take a look at, or explore in depth?
I would say to take a look at the different components. The main thing is to start off with I know we're running out of time here, is this is used mainly as a provisioning platform to first identify what image you want to assign to your nodes. Have they be the control plane nodes, the Kubernetes control plane nodes, the worker nodes, in our case, DGXs. So start up with the image, assign the category. If you need to make a group, and then have the group have a category within it, and then just understand that process, right? And then we could go deeper. We won't go into this lab, but you could go deeper and then start launching your Docker images. You could also do Jupyter notebooks, or its end goal is to deploy Kubernetes. So that's what I had on that from a high level.
Yeah, I mean, from my standpoint, it's good to understand. You're going to have to understand Kubernetes at some level when you're talking about any of the AI workloads. So it's good to use. It's probably best to run through just like what is Kubernetes refresher course or a general starting one, and then dive into BCM, because at the end of the day, your workloads are going to be set up using kind of the Kubernetes mindset. So it's probably good to have that knowledge first, and then dive right into, well, how can BCM offer that, and walk through it along with other software things that we have on WWT.com. So that would be my advice, is keep those two kind of tied to the hip a little bit.
Perfect. And another
Run
question.
AI is built on top of that also. Sorry, not to cut you off, but I know several of our guests have talked about Run AI, but Run AI needs Kubernetes to be effective. So Run AI is another layer on top of Kubernetes.
Perfect. And I guess a question, is if we talk through several different pieces of changing here, from Run AI to BCM software versions and capabilities itself constantly changing, both Chirag and Chris question again, what sort of content do you guys believe you're going to be working on next to put on WWT.com?
So we do have a day 3 learning path coming out. We're going to talk more. We're going to go deep into the HA aspect of the head node. We have a video on deploying Kubernetes. We're also going to have information on CM shell. So CM shell is the precursor to Base View. It's actually the terminal-based version of Base Command Manager. So it has more capabilities, and it's built on top of a Linux shell. We're going to have advanced features on that in our day 3. And then we're also going to talk about the cloud version, which we briefly talked about today. And then I'll let Chris talk about anything.
Before we jump to you, Chris, Chirag, you mentioned a point. You mentioned about another one, day 3 learning path coming up. Can you take 5 or 10 seconds and dive into what you have now for the day 2 learning stuff? I know this lab is a component of a larger learning path. Do you mind talking about the learning path that's there today, and what are some things outside of this lab consumers have available?
Yeah, we talk about the upgrades, how to upgrade BCM. We also talk about firmware upgrades for the different DGX nodes and various aspects like that.
Yeah, switch integrations, workload setup, provisioning. So it goes a little bit deeper. I think the day 1, what we're going through today, just kind of gets you the basics. Day 2 is like, all right, what do I do once I get it installed, right? And day 3 is like, okay, it's installed. What are some of the cooler functions that I can use, like Chirag was talking about, cloud bursting, and what are the advanced features of the shell? So that's kind of how it progresses. I got the stuff, I put the stuff in, now what do I do with it? Now the stuff's in, how do I keep progressing along further? Just to kind of simplify that there.
I appreciate it. And that content's available. Kristen Schneider posted a link in the chat here, some of the learning paths in the lab like we have today that are available. So I guess for the last minute, Chris, what are you going to be working on next? What sort of content?
So the day 3 one that Chirag kind of talked about is we're going to show, cloud bursting. We're going to have a lab that'll let you build your own Kubernetes cluster as part of this. So again, following that progression of building the entire base view, base command, kind of like a small virtual base pod, right? So that's what we're going for, is that you can do that all virtual before you go to try to put it in your production with the physical environment.
Makes sense. So with that, I'd like to kind of close it out here today. So number one, I appreciate everybody's time and the questions and the dialogue that's come in. Thank you, Chris. Thank you, Chirag, for both presenting and walking us through the lab today. A reminder that this recording will be available on WWT.com. Coming up on 6/19, we will have another hands-on live lab. This time it'll be for Aruba SD branch, so a little bit from the AI side of the world to moving to your traditional campus network side of the world. As always, I appreciate your time and hope you learned something today. With that, have a great day, everybody. Thank you.